All right, we're going to review some case studies from our BullsEye Technology, and Peyton Morrow is with us, and he's going to be able to walk us through some of the recent testing we've been doing. Peyton, thanks for being with us, and do you mind kind of introducing yourself to everyone?
Yeah, sure. My name is Peyton Morrow. I graduated from SMU with a degree in geology, and then I did a master's in geophysics. And my master's kind of focused on neural networks and seismic processing, which will somewhat directly tie to what we're going to talk to today. Now, I will date myself. That was a few years ago, and there's been a lot of improvements since then, which is exciting. But big picture, I've been in the oil and gas business since '98. I came into the business drilling conventional wells, then got into the unconventional sands and tight sands, low resistivity pay. Then next thing you know, we had shale plays. And when I did that, I was manager of the Barnett for a company called X2 Energy. Then we eventually sold to Exxon, stayed with Exxon for approximately a year. Then I branched out and started a company called Veritas Energy with Hollis Sullivan. We did that for about 3 years, sold off most of those assets, and then I teamed back up with the founders of XTO and helped them build out their operations team. And we had a company called Morningstar Partners that operated multiple entities. And then eventually I took over Founders Oil and Gas and became president of that company. And we went more conventional, drilled some wells out in West Texas, and sold that about a year ago now. And during that time is when I met Jonathan and his team, and we got our first introduction to the BullsEye tool. And that really is what leads us into case study one. So I will kind of jump into that if that's okay with you, Jonathan.
That sounds perfect. Thanks, Peyton.
Right. So when we were with Founders, we bought an old field from Conoco that was making approximately 200 barrels a day. It's an old historic field, really cool story. It was originally drilled in probably the early 20s, and then has produced up until today. So you're looking at well over 100 years of production. The original production came from a shallow formation called the San Andres, and then a deep formation called the Ellenberger. Over time, those two zones were exploited and were just kind of puffing along, and that's when we bought it. So most of the stuff in between the San Andres and Ellenberger were exploited. There wasn't much left. The field was thought to be dead. What we decided was there's a lot of leftover oil and gas in between those two formations. You had some tests that showed there were some hydrocarbons there, but nothing that was what you'd say encouraging enough just to drill a well for that one target. So we kind of took a conventional approach and applied unconventional technology to it, and we did stack pay and treated it as kind of a vertical horizontal, where we completed 2,000 feet, 2,500 feet of rock all together and produced it. And so, but with that, you don't always know where everything's coming from. So we had some experiments that we tried to do and try to get better, and that's where this tool I'll kind of explain some of the issues we had as we went through that redevelopment of the field. So moving on to the next slide. This is kind of a location map. You're off Interstate 20, just west of Midland and Odessa, in a little, I can't even say a town, but a stop called Pinwell. This is the field just north of 20 that we drilled. And moving on to one of the very first wells we drilled was an interesting well. The original field rules only allowed you to produce kind of the shallowest formation, and they gave you assigned a max rate to that formation, and that's all you could produce. And so what we were doing, if you come over here, you can see there's a Glorietta here at the top, and I also point out the Ellenberger. We focused on all the intervals in between, basically from the Devonian formation up to the Clear Fork, and sometimes the Glorietta. We drilled the well. We had various gas shows in the Glorietta, Clear Fork, Wichita, Albany, some in the Wolfcamp, and then also in the Devonian. So taking our approach, and this goes back to some of our shell background, let's go do 5 or 6 frac zones through this interval, frac it all together, and then produce it. So we ran an ESP, dropped it down basically right above perfs, and produced it. Now, we were constrained by field rules, so we can only produce at 130 barrels a day for roughly 6 months, and we kept it flat at that level for 6 months, and then it started going on a normal decline. And you can see here we started having some pump issues at about a year and a half. And when we came back, we ended up lowering the pump down into a deeper part of the wellbore, and you see you have a nice increase in production again and then start going. And at this point in time, we're having issues with the pump and some corrosion issues caused some of the choppiness, but you really got a nice wedge of production as you lower the pump to pull the pressure down on the rest of the well. And here's your cumulative plot. So very good well, exceeded expectations. I think to date, I mean, well should make 250, 300,000 barrels of oil. Really strong well. So we're very encouraged about the future of the field. We came in approximately a little over a year later, and drilled an offset well. And this is directly to the north or southwest of the existing location. And you can see some of the same formation tops. We come in the Grayburg, San Andres, Glorieta. This is where the other log picked up. Go down the Clear Fork, Wichita, Albany, Wolfcamp, Penn, and Devonian. Now, if you remember the other slide, we had a completion interval from the Devonian up to the Clear Fork. In this instance, we broke it up into multiple stages because we were going to experiment. We decided we're only going to complete, and this was before we even drilled the well, that we were going to only complete the Wichita, Albany through the Penn section and ignore the Devonian. And part of the reason, if you remember the plot from the other well, we made quite a bit of water. So we were concerned where water was coming from. The Devonian can be a prolific water producer. And so we were trying to be cautious. So we came in and just focused on the Wichita, Albany down to the Penn, and that's what's zoomed in here. This was our first stage, and we did roughly 3 stages in this interval, a lower Penn, lower Wolfcamp, a middle Wolfcamp, and Wichita, Albany frac. But what you see here on the right is I have some lines going off to the right in a horizontal manner. These are actually shows from the BullsEye. So we came in and shot this prior to completion, shot the BullsEye tool just adjacent to the surface hole location. And our tool, once we tied it back to depth, showed no shows through this entire interval, which at the time, I'm like, I've got a 40-acre offset that's going to make 250,000 barrels of oil, and then there's no way this zone's not going to make some really good oil. So I kind of discounted the tool at that time. And the joke was on me. We completed this, and we did get some oil, but it was nowhere near where we wanted to do. So we can see as we zoom into this is once again the entire wellbore where we broke it up into 2 stages. No shows, but I'm going to illustrate. This is the Devonian show that we had on the other well, and this is a Fusselman show, which is a slightly deeper formation. We also have a show up in the Clear Fork, in kind of the upper Clear Fork Glorieta interval. And then this would be up in the San Andres where we know there's a ton of water, and we had a really strong show for water with the tool as well. This caused concern. So we, after the fact, we completed the well from the Wichita, Albany to the Penn. And you can see on this lower chart here, this was the IP. It came in very underwhelming, around 100 barrels a day. And within 3.5 months, you're basically at 0. So that well came on and just, tanked. It was not a good well. We're all very disappointed, very tight, just not what we want. So we came back, completed the upper intervals where we did have shows with the tool, and the well popped up to about 150 barrels a day IP and then went on a normal decline. Okay, so that was, hindsight, the tool was showing us something that there's nothing in this interval to speak of. Yes, there was some oil and gas, but not commercial. We had very strong shows up above and below. And so had we completed the Devonian section, my guess is this well would be very similar to the previous well, where it's going to make 200,000 instead of 150,000 barrels. Still a very economic well, but we could have saved ourselves some monies by eliminating this zone, focused one stage here and then focused on the upper stages, and we've had a more economic well, which is half the battle. So one thing I'd like to point out over here is when we're looking at these shows, and I talk about a show, you can see a baseline using this red line through the Devonian show. Okay, so when we induce a signal and it comes down as a P wave and induces an event in a formation, what happens is it creates a signal that responds back. And when that occurs, we signal. And you can see here you have an increase in signal strength, and then it eventually fades back down into the baseline. This is what we're looking for in our tool, that there's a change, interface change, and the shape of this curve can directly tie to the type of substance that's in the rock, whether it's oil, gas, or water. And so the strength of this usually indicates how strong the show is, and we've seen some direct correlations, and I'll show you some more of those as we go into the other case studies. But this is what we're looking for: increase over the baseline, and this indicates a show, this indicates a show, here indicates a show, and same thing as you move up. And the blue one is obviously we know is water and has a slightly different shape, which gets into some of the technical details, but we are able to start identifying sources of oil, gas, and water based off the signal strength and the character of that curve as it bounces back up from the ground. So, but it's very interesting technology, and we're excited about where it can take us. And when I saw this, and we tied it back together, you see a case study that gives you confidence that this tool can show you where either left behind pay is or where to avoid fracking. Those are all good things to see when you're in the oil and gas business and trying to make money. So we're very excited about that.
Yeah, definitely. Thank you.
Jumping into conclusions, basically what I just said, it's able to help you show where pay and non-pay is. You can recomplete into upper pay zones, and the well, in this case, met production expectations. The BullsEye show deeper shows, which, if the well's drilled deep enough at some point in time, you could go back and get that lower zone. You'd love to have had it in the first one, but you always have the ability to drill out and go get that. And so you have reason to do that now. Future offset wells in this case would benefit from the tool. You're in a carbonate environment with discontinuous porosity. Being able to know where those pockets of oil and gas are can definitely help you high grade your drilling program and prioritize your program as you go forward. So, any questions on that one before we jump into case study 2?
No, I think that's great. It obviously kind of you illustrated obviously with the wells that you already owned and drilled at the time when you had that company, exactly what you saw in the opportunity. Because I know it was pretty funny when we first showed it to you, you weren't really that interested, but then after you guys kind of got results back, you're like, well, wait a minute, maybe we should take another look here. Exactly.
So,
excellent.
you're always a skeptic, but when you see something that shows you something, you're like, wait a minute. So, which is fun.
Absolutely. That's good.
Well,
okay.
Now
and
we're going
so there's what's the second case study here?
Yeah, so we're going to jump down to kind of Southeast Texas. Big picture, you're in kind of the Austin Chalk area. And we're going to look at, this one is not a field per se. We're going to look at individual well. And we were able to shoot 2 data points, one at the surface hole location and one at the bottom hole location. This was not a horizontal well, but a directional well. And so we're going to look at where we were at surface, where we're at bottom hole, and what the differences are. And it gave you some pretty telling results. And one thing I would like to point out, when we tie this to depth, and I'll talk about this here real quick, we used a check shot survey that was in the vicinity. And when we convert to depth, this wave that travels back up to surface moves at a much slower pace. So if your average seismic velocity, where in this case is roughly 5,000 feet per second, we're going to be 2 orders of magnitude slower. So now we're talking about 50 feet per second. So we use a pretty good ratio out in West Texas and Permian. We use a faster velocity did the same math, and we base that off check shot survey. So we base it off real science, real velocities from a P wave, and just do a 2 order of magnitude shift to get our velocity and tie back. And we're very consistent in how we apply that. So jumping into this one, what we're looking at here, I gave you a little bit different presentation. You've got the 2 data points that we took. Right here, this first kind of black with the horizontal kind of white lines cutting through it with a little bit of blue. This is shot 1, and this is shot 2. So this would be at the surface hole location. This will be at the bottom hole location. The actual drill well is right here next to it. And you can see here we have some tops, formation tops, where you follow this gamma ray curve, and you can kind of see natural inflection points, and that usually ties to the formations. Right here, you come into the first formation. This first well at surface hole location has some shows that we've generally associated with mainly water. As we move down into the formation, we get another nice gas show right here. We didn't have a real strong show. There's a few small events that you can't see on this scale, but we had a few events. And then as you move down, we have another event within this formation, and you come down to the Austin Chalk down here where we have a really nice gas show, have another show within the surface hole location, but it's a little bit dimmer than what you have just adjacent to it, which is a bottom hole location. This is one of the strongest shows we've seen in this area, where it's very strong, okay? So, and I'll illustrate that here in a moment with another view, but what I've illustrated is kind of the depths of each show. So I've made each one of these where I can turn it horizontal if I want to and show the signal like I did on the previous case study where it goes out in a horizontal manner. So each one of these ties to a show, and that way I can break it down from a geologic perspective. What formation am I in? What are the geologic parameters at that exact spot? And so there's the ability to use this as an interpretation tool and start tying things together from a geologic perspective, reservoir perspective. But for today, we're just looking at kind of big picture, okay? So really nice showing the Austin Chalk. And then as you go down a little bit deeper at the bottom hole location, shot 2, you do see another show down at the Woodbine interval. So those were kind of the primary targets in this well, was going to be the Austin Chalk and then also in the Woodbine. We would view it based off the strength we see here that your primary target should be the Austin Chalk, but generally when you complete wells, if you don't know, you start at the bottom and work your way up. So starting with the Woodbine, and we'll be very anxious to see what the full results are as they complete this well and tie data points together like we did at the Pinwell field in the previous case study.
Mm-hmm. Yep.
Kind of zooming in here, a little bit cleaner view, but between these wells, so if you're roughly 1,500 feet away at the Austin Chalk level, you have a show at surface and a show at bottom hole. That's encouraging. You see consistency. You feel pretty good about the reservoir parameters because you're seeing shows, over a broad 40-acre, area where you feel like, all right, I've got a pretty good shot here. You don't see much of a show in the Woodbine here. There is a minor show in the surface hole location, a little bit stronger show, but still very dim compared to what you have in the Austin Chalk. And I will show you a zoomed in view focusing on these 2 formations here next. So this is like the ideal show, okay? So we came in, this is your Austin Chalk. This is a strong show I discussed earlier. You can see this kind of wave formation, all right? And so this separation between the light gray and green is how much of a signal boost you got as you went through. The P wave came down where we induced our shot, came down, reflected off this formation, and had a super strong response, which indicates probably a little bit stronger show of oil versus a mix of water and gas. And oil it's very strong reflection, very strong signal shape. So we're very encouraged by that, and it carries throughout the wellbore. So perfect show through here. Really excited about what we saw. And let's compare that to what we see in the Woodbine. A little bit more subtle show. You have an increase over the baseline, but definitely not as strong as what you see in the Austin Chalk, okay? So based off what we see here and what we know today, we would say this is an okay show, but this is a really good show. So when it comes down to focusing on completions, you definitely go test this. But I think this is your bread and butter. This is where you're going to hopefully see really strong results once this zone is completed. But we are very encouraged by the shape of this curve and what it illustrates to us, and what hopefully will tie to production here in the near future.
Excellent.
So just kind of a quick conclusion. The BullsEye tool clearly showed, correlation between the two wells or two data points, with primary focus being the Austin Chalk being the most consistent. The BullsEye showed the Woodbine formation had something at both spots, but it was much weaker signal, which we equate with the lesser show. Confirmation both Woodbine currently is being tested, and the Austin Chalk productivity will come to us in the future. So we just have to be patient. But I suspect it's going to be very similar to what we saw in the West Texas program. And then any future drilling out here, going after zones like this, I think you can go do a grid pattern, identify where your best sources are of hydrocarbons based off signal strength. And when I talk about tying things together from a reservoir property, we can assign some strength or values to the strength of that signal and hopefully tie to reservoir properties, which is very encouraging and help you high grade your locations. Any questions related to the Southeast Texas?
No, I think that's perfect. Thank you.
Okay. So this next case study, this is a water well test, okay? And this is more of a confirmation that the tool can work in a shallow environment and more of a pure water play, okay? So we were looking at an oil play, and we're looking at another oil play in West Texas. And we all know water's important, right? It's a growing problem for all cities. West Coast, it's a huge issue. The Rocky Mountains, it's a huge issue, and it's becoming a bigger issue in Texas. So today's about Texas. We did West Texas, we did Southeast Texas, now we're doing more Central Texas, Gulf Coast area, and we're going to focus on water for a moment. All these spots here in this map are all water wells, and most of these are in some shape or fashion commercial to supply water to the various areas, or processed as brine fluid and treated to become fresh water. So just keep that in mind. This first cross section I have, and I'm going to qualify this, we are in an area where there's a salt dome, okay? There's been some oil and gas wells drilled adjacent to the salt dome. If I use just the data points I have in the shallower interval, I only have like one log that is halfway decent, okay? So the next cross section I'm going to show you is a little bit deeper, but all these sands do tie together, and we see it through the water wells, we see it through some logs, and they all correlate together. So when you see some different depths, I just want to qualify that I'm using some oil and gas data logs that directly tie back based off structure and other regional data that's been done that ties to the reservoir. It's just compartmentalized. But yeah, right here, you have our water well 12. You've got the 16 and the 3 and the number 3 is going to be a future well that's to be drilled. But your main horizons that's producing from is in this area here, and you see consistent shows in the 12, this well, the 16, and then hopefully the 3 when it's drilled. This is the cross section I was discussing that's a little bit deeper, but we're just going to come uphole. Oops, sorry about that. So you're a little bit deeper in formation, down dip, different part of the salt dome. But as you move the same formation up, you're looking at basically several hundred feet down to about 600 feet. And for reference, this would be about 1,000 to 1,200 feet here. You have a series of very porous sands that contribute to very high flow rates. Most of these wells produce anywhere from 65 gallons per minute to 300 gallons per minute, which are pretty strong wells. And most of these wells were originally drilled in the 1960s and maybe late 50s. So they've been producing for a long time, very prolific wells, and continue to provide water for the area. And so what we did is we, just like Penwell, just like we did in East Texas, we came and shot adjacent to known wells, and then also to a future well, which we have here, and another known well with another well that I could tie to geologically. So you can see some really nice shows right here in the heart of the perfed interval. And this well has been producing for quite a while, so that's still encouraging that you can see some water that's responding. Same thing in the number 16, very strong wells throughout, and encouraging. Then we have the one strong show here in the number 3, and we have another really strong show down in the deeper, which is kind of the next stage of development for these water wells, 1,000-1,200 foot range, and focus on these shows here. And so we felt very good when we tied these curves together, and can see consistent shows throughout the area and that tie to these sands. And so once again, another application for the tool to identify shallow water in areas that we know that it produces. And so just really encouraging news that, you can identify shallow water in the sub 1,000 feet, 600 to 1,000 feet, a little bit shallower to 300 feet, and feel really comfortable with what you're seeing here. Any questions related to this one, Jonathan?
No, excellent. I think that's great. It's good to see obviously different use cases of the technology as we continue to test different applications in different kinds of fields, and seeing the same kind of results with water assets as we are over on the oil and gas side.
Yep. So I'm really excited about it. It's fun to see where they take it. Hopefully, when they drill this pad number 3, we'll get some real world data to tie it together. And I suspect, just like Penwell, it's going to give you something. And I'll be real curious what these deeper zones do as they have to start branching out down to those. So, but yeah, it's going to be fun to see where it goes.
That's perfect. Yeah, thanks, Peyton. I appreciate kind of the debrief of these 3 case studies. I know we've got more we've shot over the last 2 months, and we're going to be preparing. But if anyone has technical questions on the technology and kind of your understanding up to this point, is it okay for them to be connected to you?
Absolutely. Would love to dive down a little bit deeper and answer some more questions if anybody has any.
Perfect. Thank you so much for your time, and we appreciate the assessment here.
All right. Thank you.
Excellent. Thanks.